So we are looking at finding the zeros in these functions like we've done in the past. So when you find the zeros, all you're doing is setting it equal to 0 and solving. So 0 equals negative 3x plus 2. And then we solve for 0, or for x. And so we get negative 2 is equal to negative 3x. Divide both sides by negative 3. And so 2/3 is equal to x. How do I solve the second equation? Because I'll set it equal to 0, but I can't isolate the x and have an x squared there. What do I do to help get that to where I can isolate it? So we can solve it by either factoring it or using quadratic formula. And so if the a is prime, so in other words, we have a 1 in front of the x squared. That's prime. And the c is prime. It's often the best way, easiest way is to factor it. So when you use that box, the x squared goes here, the 2 goes here. And this is 2x squared, the product of those two, and negative 3x goes here. So what multiplies to give me 2x squared, but will add to give me a negative 3x? What's two numbers that can multiply to give me a positive 2? 1 and 2. And they both need to be negative if we want it to be a positive product. So negative 1x, negative 2x. So now I'm looking at factoring. The first column, what can I pull out of both of those? What's the same in both? They both have an x. And the second column, what can divide into both 1 and 2? Just a 1. And the closest sign is negative, so negative. So my first factor is x minus 1. My second factor, what can go into this first row?
X.
Okay, what can go into the second row?
Negative 2.
So that gives me my second parenthesis. Now all I do is set my parentheses equal to 0 and solve. Oops. So x equals 1 and x equals 2 are my two solutions. Now let's go on to 3. Question 3, I have x minus 2 and then parenthesis x squared minus 1. So I'm going to set it equal to 0. It's already semi-factored out, so I'm just going to set those factors equal to 0. As long as it's a binomial for both, you can easily do this. And so we have x is equal to 2. Well, x squared is equal to 1. So do I have it solved for x yet? No, you said? What do I need to do? How do I get rid of that squared?
Square root.
And remember, when you take a square root, a positive and negative goes in front of it. So these are my 3 solutions. So there's 3 different times that's going to cross the x-axis. So for today, what we're going to be doing is taking it from where does it cross the x-axis? Where are my zeros? and going back to the equation or going to the graph. And so we're going to be looking at cubic functions. So that means we're going to be looking at ones that have opposite directions on my ends. And we're going to find out different properties, and we're going to see what's similar and what's different. How do they compare, and what makes them what they are? So on question 1, it says that we want to take and sketch one with the zeros at 0, 2, and 5. I want you to go ahead and perform that sketch. So when I sketched my graph, first thing I did is I put my zeros. And so my zeros were at x equals 0, 2, and -5. Now, it doesn't tell me any more information. So I don't know which way my graph's coming from, but I chose just to go ahead and do a basic positive one, positive A, which means my graph could look something like this. What are some things that are the same between my graph and your graph? Did we all go through the same x-intercepts?
Yes.
Okay. Did we all have 2 extrema? So we all went through the same x-intercepts. We all had 2 extrema. Did we all have our tails go opposite directions? Yeah. Did we all have all domain?
Mm-hmm.
Okay. Did we all cover all range? Yeah. Things that are different. You may have had different values. You may have had different max and mins, relative max and mins. You may have had different, meaning you could have gone up higher or lower in your hills and valleys. And you may have had a different A. You may have chosen A to be negative, and therefore it gone the opposite direction. So I want you to look at B. I want you to graph B. So this time we have some information that's a little bit different. It tells us we have a 0 at -3, and then at x equals 4 we have a multiplicity of 2. So what's going to be the difference between these two?
One of them was going to pass and the other one's going to bounce off of it.
This one's going to pass. This is going to bounce. So at -3, we're just passing through, and at 4, we're bouncing off. Oops, let me go down far enough. So here's an example of a positive A version of that. You could have started up here and then bounced off and come back down. But similarities and differences are going to be the same thing. We're going to have the same, we have 2 extrema. We have, this time, only 2 x-intercepts. So our same, so we have the same number of x-intercepts. We have our tails going in opposite direction. We have covered all our range, all our domain. So those are all things that you need to list like we did last time. But what is different this time from the last problem? Did we go through both places? No. But if we were to compare between all of us in this room, we would have a very similar graph in the fact that we had both had a bounce there. It may be bouncing going down or bouncing going up, depending on what you chose for your A. So Derek and Alex disagree on which function, when multiplied together, would build a cubic function with zeros at 5 and -1, and -1 is going to have a multiplicity of 2, meaning it's going to bounce. So they both think these two spots are going to be affected. So this one is supposed to bounce, and that one's supposed to cross. Is this correct? Is one of them correct and one of them wrong? So let's go through it like we did back at the beginning of this chapter. We multiply. So on this side of it, we have a negative times a positive. So in that section, what would it be?
Negative.
Negative. Going to the right of it, we have a positive and a negative. So what's it going to be until I get to the next spot?
Negative.
And then now we have a positive and a positive. It's going to cross and go 3. Okay. So now let's look at to the left of that -3. Positive, negative, and then negative. What would that section be? A positive times 2 negatives.
Positive.
Positive. In this next section, we have a positive times 2 negatives, so it's a positive again. Let's see what happens when we get to this point. We have 2 positives and 1 negative, so what am I going to do next?
Negative.
Go negative. So, did these both cross at x equals 5 and bounce at x equals -1?
Mm-hmm.
So are they both correct?
Yeah.
Yeah. They're both different ways you could follow it, fit the same set of rules. So you may want a calculator for this, because we're going to go through and I want you to graph each of these graphs. So in that top row, we had x equals, or f of x equals x. That's the first one. So that's just a linear graph going through the origin. Where would the next one go through? G of x. What's the y-intercept on that one? 1. And this point right here is the x-intercept will be -1. So here, what's our y-intercept?
Negative.
And my slope is still +1. And then j of x, we have a +1 y-intercept. We go down with a negative slope. Make it a -1. So now let's look at the next one. For m of x is x squared. So that means it goes through the origin. It's going to curve both sides. Where does the p of x go through? What is the y-intercept on p of x? It's 1. It's always this number back here. and then it's going to curve out. On our next one, r of x is equal to x minus 1 squared. So that means I go right 1 and go through the origin, or go through the x-axis. And the last one, we have w of x is equal to negative x minus 1, x plus 1. And so that means we're going down with two intercepts, negative 1 and 1. Oops. Okay, now we're going to use this information to help us graph. And so if I want an imaginary 0, that means if I want something imaginary, what can it not do? Can't cross the x-axis. So which of these is going to give me an imaginary root? Well, this one right here isn't going to go through the x-axis. So p of x is one of my imaginary roots. Is there any other ones? So that gets care of my two imaginary roots. And a real 0, well, any real 0 is going to be this first row. And so depending on which one you chose, so let's say you chose x plus 1 and x squared plus 1 as the two things for your f of x. So that means at negative 1 I have a x-intercept, and at 1 I'm going to have a flattening point. So that means my graph is going to kind of curve up here, flatten out, and curve back out. So we're all going to have a vertical shift of 1. And then we're going to be all having just one x-intercept. I want y'all to do B, C, D, and E, and F. One of those is going to be not possible. And that's your homework.